Folks, welcome to Lesson 18. You're almost ready for Unit 3 test. Yay. This is the second time I'm doing this video and I'm so excited. All right, here we go. So we're talking about Lesson 18, confidence intervals for a population proportion. Population proportion. Let me give you an example of what I'm talking about. Of course, as you know, we have the GOP and the Democratic candidates for the 2016 election. And back in April, we had three candidates who were studying in particular, Rubio, Jeb Bush, and Mike Huckabee. And the problem was these people are being held back by their lack of familiarity. That's very interesting. So at this time in the previous election, 92% of the people were familiar with the Democrat, 91 were familiar with the Republican, but now it's a different ball game. Now we have 76% that are familiar with Jeb Bush, and then Huckabee is 72%. So the question is, how are they going to match up election-wise with Hillary Clinton? Okay, that's a good question. So this is a reputable organization that has done the study. Now, in this particular paragraph, the method of the survey is given, and basically they're looking at 653 people in this poll, okay? Of course, they're 18 and older, they're Democrat or Democratic leaning. Another thing here, they were telephone interviews. But I want to point out a couple things. You know N now. You also know that what the margin of sampling error, that is what we're talking about here, is 5%. Also notice, it is in black and white, 95% confidence interval. Of course, what that means is the following. If you take the values and go plus or minus the margin of error, you're going to see that 77% and 71%, really Jeb Bush is not guaranteed to win. Matter of fact, that is called a statistical dead heat. All right, please don't forget here as we're moving on here please do the task. This is the minimum of folks to do. So I hope that helps you out. Here's a problem. I'd like to ask you to pause and answer two questions. Give me one fact and try to tell me what we're supposed to find. Okay, hope you're back. One fact I would say would be the amount of people that buckle up is 320 out of 400. And another thing that I want to answer is we're trying to find the population proportion that claim to always buckle up. That would be an important thing for an insurance company to know. And you may say, well, they don't need to know that today. Well, they are constantly adjusting their rates based upon what's happening in the culture. And there's a lot of factors that are involved in that. And statistics is a big part of the decision-making process. Let's take a moment and we're just going to squeeze down the notes to the most bare minimum so that we can make sense of this lesson. Here we go. Okay, don't forget, when we're talking about standard error of the mean, we're going to use a new formula. Square root of p hat times the complement over n. So remember that. Margin of error is the critical value times the standard error. And then here's your confidence interval. A couple things that are really important to point out. Let's go back over here to the assumptions. We're assuming that there's a random sample. We're assuming that the population is 20 times the sample. That's important. We're assuming there's only two categories. You think you're in favor of Mike Huckabee or you're not in favor of Mike Huckabee. And then n is greater than or equal to 10 for each of the categories. That's important to remember as well. Here's something over here we want to know. To reduce the margin of error, we could increase n. That's always a good idea. Now I am trying to remember why I drew this over here. Oh, this is your boss wants you to do a telephone poll, and he wants to know with 99% certainty what people are going to vote for, the Democrat or the Republican. Well, if he wants to be 99% certain in the population, you're going to have to do a lot of calling, okay? Now to find n, here's a little formula, okay? It's the sample proportion times a complement times this CV over m squared. Now sometimes you don't know your p hat. If you don't know your p hat, some people use the previous value. Like let's say they did a survey in February about the same thing. They may use that value in their reporting of the statistics. You may or may not know about that. And again, a lot of your confidence in these reports are based upon the reputation of the organization. You know, or you could just assume that p hat is 0.5. If p hat is 0.5, then your formula up here just reduces to a simpler formula, 0.25 times blah. Don't forget to round up like we did last time. All right, over here, what's the procedure? All right, find p hat, find a critical value, find your standard error, the mean to get the margin of error. And don't forget your confidence interval. This is what you're looking for, right? That's the goal. Your sample proportion plus or minus the margin of error. And don't forget, interpret. Make Joe Blow on the street understand what you're talking about. Isn't that what the journalists trying to do with the reporting of the political polls? We certainly hope so. A couple things to point out. Make sure you know that P is the population proportion. X is the number of individuals that are for something, or what you're wanting, category that you're wanting. N is the sample size, and p hat is the sample proportion. So remember the little formula here. P hat is X over N. Hopefully that made sense. Also, don't forget, I went over this before, I'm just showing you that I didn't know what I was talking about. So that's the standard error, and your margin of error is your critical value. That's your critical value times the standard error. Enough said there. All right, let's go back to our problem. So let's take a moment and review. First of all, it's about an insurance company and people needing to buckle up. That's important for insurance companies. How many people did they poll or ask or whatever? 400. How many said they always buckle up? 320. So of that sample, there were 80% or 0.8. Okay, that's going to be our p hat for that sample proportion. Don't forget, you got to find your standard error of the mean. Standard error of the mean, you're going to use that little formula. And that happens to be 0.02. So if we take this and put it in our calculator, I'm going to go 0.8 minus 1.96 times 0.02. And when I do that, I get 0.761. And then I'm going to do 0.8 plus 1.96 times 0.02, and I should get 0.839. Okay, can we interpret it? We are not going to write it all out. 95% confident that the amount of people in the population who buckle up, always buckle up, are between 76 and 84% of the population. Okay. Now see how we boiled it down to a statement people can understand? And there you go. Hopefully that helps you out. Don't forget, you can do this on the calculator. So let's do an example. Okay, folks, in my calculator, I went to my stat test. I'm going all the way down here to A, which is 1 proportion Z interval. Okay, so I'm going to hit enter. Now, how many people claimed to buckle up in this sample? Was 320. How many people did we poll? Okay, and remember what we were looking for. It was 95%, 0.95. Okay, and now you may remember I said something like 76% to 84. And there's our p hat right there. Hopefully that helps you out. Okay, you may want to pause this and then look at the question and see what I did. I'm just going to point out what's going on. So here we have insurance companies. They want to be sure about something, and they want to be 95% confident, and they have a population proportionate to, they want to estimate it within 0.03. So bottom line, we're going to use that find n without knowing p. So without knowing p, I'm going to put 0.25. Then I'm going to put my 1.96 over 0.03, square that, and I'm going to get 1067.11. Always round up. So I need to poll 1,068 drivers. You see how powerful that is? Okay. So one thing you want to know is if you can narrow down your proportion by a good estimate, that's going to help you. And if your margin of error doesn't need to be really big, like 99%, you can get a good estimate. And as you can see, there's some possibility with some people not being totally honest with their method. And that gives statistics really a bad name. And this is an important thing we can get out of this class. All right, now this is really a good slide. You saw it in the notes, and I do have a better example in the resources there. But it's just telling you kind of how to categorize the possibilities. Remember, if n is greater than 30, I could use a z method. If the population is approximately normal, if it's not, and then I'm in trouble. And I got this little box over here, consult a statistician. Well, anyway, so the use of Z and the use of T, a really good slide. Hope it helps you out. Again, I did spend more time than I'm willing to admit in making sure I understand the exercise questions and can explain them to you. So I think that's important for anyone interested in doing a good job with this. And that is available for you, so hey, take advantage of it. All right, let's talk about this for a second. Okay, please remember, all of these resources are available to you. And so if you need it, please take advantage of that. And don't forget the tons of other resources as well. Oh, hi, I was just studying my quiz. And I want to let you know that I got a perfect score on this quiz the first time I took it, okay? And of course, let me give you the hints. Here's a top secret thing. Number 1, know the material. Number 2, know the steps. And when you're doing a problem on your quiz, write some things down. And think about it. You could do it longhand if you want to. You could use a calculator. I used a calculator on this, but I did write some notes down and got a lot of really good success from that and felt good that I was able to do some complicated things. I certainly want to wish each one well as you're getting ready for the Unit 3 test. And I do hope you enjoy, all of my little pieces of advice here, okay? And I certainly wish you well. I hope that you're gaining something from the class as you keep moving forward. Best wishes.